Okay, the last basic probability is this idea of not. How does not really work? It kind of works like this. Imagine you had like, I don't know, a dice and you're trying to figure out the odds of it. So like here's 1, here's 2, here's 3. Let's say the probability of getting 1. What's the probability of getting 1? Well, the probability of getting 1 is there's only one side out of the 6, so it's 1 out of 6. But the probability of not getting 1 is, well, the other ones, right? So it's 2, it's 3, it's 4, 5, and 6. That's 5 numbers out of 6. This whole idea of not is really simple, actually. Let me just define it for you. The probability of not A, whatever the event is 1 minus probability of A. We can kind of see that in this example. The probability of not 1 is the probability of 1 minus the probability of 1. And so what I can do is just the 1 minus 1 out of 6, giving me 5 out of 6. Okay, that's cool and all, and it's honestly really simple to just think of at first. Is there a harder example? And the answer is yes. Say, for example, I wanted to find that I'm guessing 4 questions on a test. Let's just say there's 4 answer choices, A, B, C, and D. What is the probability of getting at least 1 right? So you might be asking yourself, okay, like, wait, isn't it just like 1 out of 4? Because I can just get 1 out of the 4 questions. Not quite. So the idea of at least 1 right means I can get either 1 question right, 2 questions right, 3 questions right, 4 questions right. So notice that those are so many options, and I have to figure out each and every single possibility. Instead of doing that, one of the things that we like to do as mathematicians is, well, make it easier for ourselves. Why do more work when less work is better? I like to think of it like this. Anytime I see the word at least, I think of the opposite. Well, if I get 1 or 2 or 3 or 4 right, then the opposite is getting none of them right. So 0 right. And so I'm going to write this as a note, that the opposite, kind of like the idea of not, of at least something is none or no. So if I had to write this, the probability of at least 1 is going to be this. It's going to be the opposite. So 1 minus its opposite, which is getting none right. Well, let's see how that works out. So if I got none of them right, I have to think of it like this. If I got none of them right, that means that the first answer is wrong. The first question is wrong. Then the second one is wrong. Then the third is wrong. Then the fourth is wrong. Because that's what it means by none of them being right. All of them are wrong. So let's figure out each of these probabilities. How do I figure out that the probability of my answer choice is wrong? Well, we can think of it like this. If there's 4 answer choices, A, B, C, or D, only one of them is right. Think of the opposite. If 1 is right, then the other 3 choices are wrong. And so here's what I'm going to write. I'm going to write 3 out of 4. The first one being wrong means I chose these 3. These are wrong. This is right. And so since I have the difference between right or wrong, that's the first question. 3 out of 4 chances are wrong. The second one being wrong means that I have to multiply it because I got it also wrong. That's and. So I'm going to multiply by 3 over 4. Oh, there it is again, third question. So I have to multiply it a third time. And then the fourth, I have to do it one more time. Once I have this, I'm able to then simplify it, multiply and all that stuff. Another way you could have wrote this is 1 minus 3 out of 4, because that's what you get wrong, 4 times. Because why is it 4? Because it's 4 questions. If I did 5 questions, I would have changed this to 5. If I had 10 questions, it would have been 10, so on and so forth. Because of this, we're going to now do some exponent rules. This is 3 over 4 over 4 over 4, making us 1 minus 3 to the power of 4, which is 81, and 4 over 4, which is 256. This gives us our final answer of 175 over 256. Let's see if we can do this again. So let's say I'm guessing, or let's say I have a spinner. This time it has, I don't know, like 6 choices. 1, 2, 3, 4, 5, 6. Let's just say that this one is the winning one. Let's say I spin 3 times. What is the probability that I win at least 1? Because it's realistic. I want to at least win 1. That way I can get the prize. The opposite of at least is none. So the probability is 1 minus getting no win. So the first spin, I lost. If only one of them is winning, the opposite is losing. 5 out of 6. Because these in red are clearly losing. Because of that, that's the first spin. The second spin, did I win? No, right? The second one, I lost. So this is the first loss, second loss, and then the third I lost. So I also multiply by 5 over 6. Once I'm able to do that, I'm able to multiply. So I'm going to do 5 times 5 times 5. That gives me 125. 6 times 6 times 6 gives me 216. I subtract these, giving me, I believe, 91 over 256. And so that's the whole idea of not. It's a lot simpler than at first compared to and or, but I gave you guys pretty hard examples when it comes to using it in a different, unique way. Think of it not using not, but using a new word called at least. At least means, and the opposite of it is none at all. And we can kind of see that we did 1 minus all that subtraction. But that kind of wraps it up for the basic probability.